Hello everyone. Today we will look into collision. So what is collision? So when two objects meet each other and at least one of them is moving, then we say that this phenomenon is collision. Now you may recall while proving conservation of momentum, we did use collision in our ninth standard. So we will expand upon that. We will see how to apply conservation of momentum to find the final velocities after collision of the two bodies. See, right now we are tackling collision in one dimension, only single dimension. We aren't even going into two-dimensional collision. Okay, we have that in our portion, but right now we will just look at one-dimensional collision. Now here we have three cases in total, out of which in this video we will cover two cases, which is elastic collision and perfectly inelastic collision. So what happens in elastic collision? In elastic collision, the kinetic energy of the system will be conserved. Conserved is a big word, but what does that mean? It means the kinetic energy initially and the kinetic energy finally both will be equal. That is, total kinetic energy of the system will not change. On the other hand, what happens in perfectly inelastic collision? There a lot of loss of kinetic energy takes place and finally both the objects will start moving together. The case in between is called inelastic collision, which we will tackle during our lectures. So first we will look at elastic collision. So what did we just discuss? We discussed that in elastic collision, kinetic energy will be conserved. And of course, momentum will also be conserved. Okay, so in elastic collision, momentum and kinetic energy both will be conserved. Okay, so let us establish parameters. So we have two objects of mass m1 and m2, and initially both are moving with velocities u1 and u2. Okay, both are moving with velocities u1 and u2. Now we have taken right direction to be positive. So this side is positive side. Okay, all the values in this direction will be positive. Now it is given that u1 is greater than u2. Unless and until u1 is greater than u2, m1 cannot catch up with m2 and collision will not take place. So it has been assumed, it has been given that u1 is greater than u2. So after some time, they will collide, and after that, they will again start moving with now new velocities. So mass m1, mass m2. Here we have v1, which is final velocity, and here we have v2. Now we know u1, we know u2, we know their masses, but we do not know v1 and we do not know v2. That is what we need to find. So to find v1 and v2. So that is the question that we will tackle right now. So we have two properties that we can use. Kinetic energy is being conserved and momentum is being conserved. So first write the statement for momentum being conserved. So as momentum is being conserved, total initial momentum will be equal to total final momentum. So what is total initial momentum? So it will be momentum of object 1 plus momentum of object 2. So m1 u1 plus m2 u2, and this will be equal to total final momentum. So that will be m1 v1 plus m2 v2. Okay, we will just rearrange this a bit. So we will get m1 u1 minus v1 equal to m2 v2 minus u2. So we will get m1 upon m2 to be equal to v2 minus u2 upon u1 minus v1. So keep track of u, v and 1 and 2. Otherwise it will get extremely confusing. Okay. Now let us move to the second part, which is conservation of kinetic energy. That means total kinetic energy initially will be equal to total kinetic energy after the collision. So let us write the expression for total kinetic energy before collision. So that will be half m1 u1 square plus half m2 u2 square, and that is now equal to final kinetic energy. Now expression would be half m1 v1 square plus half m2 v2 square. Now 1 by 2, 1 by 2, 1 by 2 will cancel from each term. So we will rearrange this a bit and get m1 in bracket u1 square minus v1 square is equal to m2 in bracket v2 square minus u2 square. Therefore we get m1 upon m2 is equal to v2 square minus u2 square upon u1 square minus v1 square. So let's say this is 1 and this is 2. Therefore from 1 and 2, what will we obtain? So LHS are equal, so RHS will also be equal. Therefore v2 minus u2 upon u1 minus v1 is equal to v2 square up minus u2 square upon u1 square minus v1 square. Now here we can apply the identity a square minus b square is equal to a plus b into a minus b. So this will become v2 minus u2 into v2 plus u2 divided by u1 minus v1 into u1 plus v1. Okay. Therefore this will become v2 minus u2 upon u1 minus v1 is equal to v2 minus u2 upon u1 minus v1 into v2 plus u2 upon u1 plus v1. So these terms will get cancelled and therefore we will obtain u1 plus v1 is equal to v2 plus u2. Now what we will do is we will write v2 in terms of u1, u2 and v1. Therefore v2 is equal to v1 plus u1 minus u2. Okay, so now we have obtained v2 in terms of v1, u1 and u2, but that is not enough. Initially we just knew m1, m2 and u1, u2, so we also have to eliminate v1. Now what we will do is we will plug in the value of v2 in equation number 1. Okay, so what we will get is m1 upon m2 is equal to v2 is v1 plus u1 minus u2 divided by u1 minus v1. So we will cross multiply and we will get m1 u1 minus m1 v1 is equal to m2 v1 plus m2 u1 minus twice m2 u2. Okay, so rearranging, we will bring all the v1 terms to one side. Therefore, we will get m1 minus m2 u1 plus 2m2 u2 to be equal to m1 plus m2 into v1. Therefore, v1 will become m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2. So this is the expression for the velocity of the first object. Now this was a bit tedious, but if you look at it, it is pretty simple. You just have a lot of variables and have to carefully arrange and rearrange them to obtain this expression. But are we done? Of course not. We still have to find V2. What was V2? So let's say this is 3. Therefore, if we put value of V1 in expression number 3, we will obtain V2. Therefore, V2 will become m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2 plus u1 minus u2. Therefore, after simplifying, we will obtain 2m1 u1 upon m1 plus m2 plus m2 minus m1 upon m1 plus m2 u2. Okay, so these will be the expressions for v1 and v2. So this was extremely tedious but extremely necessary. See, we are still dealing with motion in just one direction, and yet everything has become so complicated. This was for elastic motion. This motion can be seen when a player hits billiard balls. Okay, so balls are nice and round, they move in just one direction, so their elastic motion will take place. Now when we look at perfectly inelastic motion, our life will be a little bit easier. Or will it be? Let's check it out. So, perfectly inelastic collision. Now, as we discussed at the beginning, what happens here? Here, when the two objects collide, after the collision, they will continue to move together. Okay. So, two objects m1, m2 moving with velocities u1 and u2. Of course, u1 we are assuming to be greater than u2, otherwise collision will not take place. So, after collision, they move with common velocity v. Okay, and the total body will have now the mass of m1 plus m2. Now let's see which are the properties that will be satisfied. The only property is conservation of momentum. Okay, kinetic energy will not be conserved. That happens in elastic motion, not in inelastic motion. Now then, where does the energy go? Because you know, energy can neither be created nor be destroyed, just can be converted from one form to another. So where does it go? It goes into other types of energy. So it may be thermal energy, light energy, sound energy. So consider two cars crashing into one another. So after the crash, let's say they move together. So where would the energy go? the energy would go in the sound of the crash. The energy would go in the heating of the bodies of the cars. Okay, so there the kinetic energy will be lost. We only have conservation of momentum, but we just have to find final velocity v because they have common final velocity. So let us write the expression. Total initial momentum is equal to total final momentum. So total initial momentum will be m1u1 plus m2u2, that will be total final momentum. So total final momentum is, total mass is m1 plus m2 and velocity is v. So m1 u1 plus m2 u2 becomes m1 plus m2 into v. We just need to find v. So v will become m1 u1 plus m2 u2 divided by m1 plus m2. Extremely easy finding the final velocity. But will this be enough? The main thing here is kinetic energy is being lost. So we need to know how much kinetic energy has been lost. So to find lost kinetic energy will be initial kinetic energy minus final kinetic energy. Okay, kinetic energy which is initially present in the system, that is kinetic energy of body 1 and body 2, minus kinetic energy of the final system. So when they combine to form mass of m1 plus m2 with velocity v, what will be that kinetic energy? We have to subtract that from initial kinetic energy to get how much kinetic energy has been lost. So it will be lost to sound energy, light energy, heat energy. Okay. So let's see. What will be initial kinetic energy? Half m1 u1 square plus half m2 u2 square. So this will be initial kinetic energy, and from that we will subtract final kinetic energy. So let us write final kinetic energy. Final kinetic energy will be half. Now mass is m1 plus m2. And velocity is m1 u1 plus m2 u2 upon m1 plus m2. So m1 u1 plus m2 u2 upon m1 plus m2, and that's square. I will just change these brackets to square brackets so that it will be easier. So this will become half m1 u1 square plus half m2 u2 square minus now inside we get 1 by 2 multiplied by m1 plus m2 into m1 u1 plus m2 u2 bracket square upon m1 plus m2 into m1 plus m2. Okay, so we cancel these m1 plus m2, m1 plus m2. Therefore we get, now we will expand this bracket. Okay, half m1 u1 square plus half m2 u2 square minus, now m1 u1 plus m2 u2 bracket square, we can use the identity a plus b bracket square gives us a square plus b square plus 2ab. So this will give us m1 square u1 square plus m2 square u2 square plus 2 m1 m2 u1 u2, and we will divide by 2 m1 plus m2. Now for the first two terms we will multiply both the numerator and the denominator by m1 plus m2. Therefore, we will get m1 u1 square into m1 plus m2 because we will get the common denominator plus m2 u2 square m1 plus m2 minus we will just remove the brackets, so we will change the sign of all the terms inside. So we will get m1 square u1 square minus m2 square u2 square m2 square u2 square minus 2 m1 m2 u1 u2, and we will divide this whole expression by 2 m1 plus m2. So let's see what we get. m1 u1 square into m1 will give us m1 square u1 square plus m1 m2 u1 square plus m1 m2 u2 square plus m2 square u2 square minus we have m1 square u1 square minus m2 square u2 square minus 2 m1 m2 u1 u2, and divide this whole thing by 2 m1 plus m2. Okay, now we have m1 square u1 square minus m1 square u1 square and m2 square u2 square and minus m2 square u2 square. So these terms will get cancelled and we will get m1 m2 u1 square plus m1 m2 u2 square minus 2 m1 m2 u1 u2 divided by twice of m1 plus m2. Hence, if we take m1 and m2 common from the numerator, we get m1 m2 into, in bracket we get u1 square plus u2 square minus 2 u1 u2 divided by 2 m1 plus m2. But if you look carefully, u1 square plus u2 square minus 2 u1 u2 is of the form a square plus b square minus 2ab. Therefore, you can write it as u1 minus u2 bracket square. So this will be m1 m2 into u1 minus u2 bracket square upon 2 m1 plus m2. Okay, so lost kinetic energy will be 1 by 2 m1 m2 upon m1 plus m2 into u1 minus u2 bracket square. So this much kinetic energy will be lost in perfectly inelastic collision, not just any inelastic collision, perfectly inelastic collision, because only in that case the two objects will move together. Otherwise, some energy will be lost and objects will move separately. That is a little bit difficult than these calculations, so we will cover that in the lecture. Hope you understood these collisions. Hope you understood what is elastic collision, what is inelastic collision, what is perfectly inelastic collision.